Hello everyone, myself Aniket. Today we are going to do a new question of computer oriented numerical mathematics. So the question is, what is partial pivoting and right pivotal condensation algorithm? When performing Gaussian elimination, the diagonal element that one uses during the elimination procedure is called the pivot. To obtain the correct multiple, one uses the pivot as the divisor to the elements below the pivot. Gaussian elimination in this form will fail if the pivot is 0. In this situation, a row interchange must be performed. Even if the pivot is not initially 0, a small value can result in big round of errors. For every large matrices, one can easily lose all accuracy in the solution. To avoid this round of errors arising from small pivots, row interchanges are made, and this technique is called partial pivoting. Now, algorithm of pivotal condensation. For k equals to 1 to n minus 1 in steps of 1 do max is modulus of akk, p is n, and for m equals to k plus 1 to n in steps of 1 do if modulus of akm is greater than max, then begin, and max is modulus of a min, and p is m for, and for if max is less than equals to e, then begin. Write ill condition equation. Stop and else if p equals to k, then exit to 3. For q equals to k to n plus 1 in steps of 1, do temp where akq akq is apq is temp, and for. Thank you. Hello everyone, myself Aniket Jain, and today we are going to discuss another question of computer oriented numerical mathematics. So, the question is, explain refinement solution of ill conditioned equation. So, when solution is ill conditioned linear equation, a refinement solution is a technique used to improve the accuracy of the computed solution. Ill conditioned statements of equations are those in which small changes in the input data or can lead to large changes in the solution. This can make it challenging to obtain accurate and reliable results, especially in numerical computations. The refinement process aims to mitigate the effects of ill conditioning by iterating, improving an initial solution. Here are some general steps involved in the refinement solution of ill-conditioned equation. So the first step is initial solution. Start with an initial estimation of the solution obtained through a numerical method such as Gaussian elimination or iterative method like the Jacobi or Gauss-Seidel method. Second step is compute residuals. Calculate the residuals, which represent the difference between the actual right-hand side of the equations and the product of the coefficient matrix and the current solution estimate. So the residual vector is r equals to b minus ax. Here x is the coefficient matrix, x is the current solution estimate, and b is the right-hand side vector. The third step is compute correction. Solve a modified system of equations to obtain a correction vector that, when added to the current solution estimate, will reduce the residuals. Modified system is a delta x equals to r. Here delta x is the correction vector. Update solution is fourth step. Add the correction vector to the current solution estimate to obtain an improved solution. So the updated solution is x new equals to x plus delta x. Check convergence is a fifth step. Check whether the solution has converged to a sufficient accurate result. This may involve checking the magnitude of the residuals or comparing the new solution with the previous one. Sixth step is iteration. If convergence criteria are not met, repeat the process by using the updated solution as the new initial estimate and iterating until the solution converges. Thank you. Hello everyone, my name is Aniket Chen, and today we are going to do another question of computer oriented numerical mathematics. So the question is write algorithm for forward difference interpolation method. So the algorithm is first read n and x. For I equals to 1 to n by 1, do read xi by I. And for if x is less than x1 or x is greater than xn, then print value lies outside tabulated range. Exit. And if set I equals to 1 while x is greater than xi, do I equals to I plus 1. And while k equals to I minus 1, u equals to x minus xk upon xk plus 1 minus xk. Now compute the elements of forward difference table. Now for j equals to 1 to n minus 1 by 1, do for I equals to 1 to n minus j by 1. Do if j is equals to 1, then dij equals to yi equals to 1 minus yi. Else dij equals to di plus 1 j minus 1 minus di j minus 1. And if and for set sum equals to yk. Now for I equals to 1 to n minus k by 1, do prod equals to 1.0. For j equals to 0 to I minus 1 by 1, do prod equals to prod into u minus j. And for thank you. Hello everyone, myself Aniket Jain, and today we are going to discuss another question of computer oriented numerical mathematics. So the question is compare iterative method with directive methods for solving system of simultaneous equation. Direct method. Direct method are ways of solving system of simultaneous equation through a finite number of steps. These ways of solving equation can be used to solve any non-singular matrix. Example, Gaussian elimination and Gauss-Jordan methods. When solving system of equation using these direct methods, we take a set of numbers of steps which as convert our system of equation to an argumented matrix, then turn to an upper triangular matrix, then solve. So after a set number of steps, we arrive at a final solution. Iterative method. Iterative methods are different than direct numerical methods in that they do not necessarily stop after a certain number of steps. By that I mean they will continue to iterate, which means to do again or repeat with a greater guess until we get a sufficient amount of error. Example, Gauss-Seidel and Jacobi iteration. Additionally, when using iterative solvers, you need an initial guess to begin with. In certain terms of actual computation, direct methods are much more computational heavy as everything in your matrix is being solved in one computational step, which requires the whole matrix to actively be used continuously, whereas in iterative method the problem is broken up into branches of minor steps, which is why iterative methods are usually performed for larger equations. Thank you. Hello everyone, my name is Aniket Chen, and today we are going to do another question of computer-oriented numerical mathematics. So the question is write algorithm for Lagrange's interpolation method. So the algorithm is start, read number of data and read data xi and yi for I equals to 1 don't and read value of independent variables say xp whose corresponding value of dependent say yp is to be determined. Initialize yp equals to 0 for I equals to 1 to n, set p equals to 1 for j equals to 1 to n. If I is not equals to j, then calculate p equals to p into xp minus xj divided by xi minus xj. And if not j, calculate yp equals to yp plus p into yi. Next, I display value of yp as interpolated value. Stop. Thank you.